So this week we're going to look at basic probability. Don't get too concerned about that. We're going to look at really basic probability, but believe it or not, our students are actually expected to understand very, again, basic forms of probability, as in what's the chance something could happen, give it a list of possibilities, what's the probability of such and such happening. So we're going to keep it pretty general. But today I'm going to show you kind of some easy classroom ideas for you to teach concepts of probability. So probability is just the chance an event will occur. The formula for it is always the number of desired outcomes goes on top. It's a ratio. So in other words, what you want to happen goes on top, or how many of those there are, over the total number of outcomes on the bottom. Okay, so one of the more basic forms of probability or ways to show probability is with a coin flip. So if a coin is flipped, as long as there's nothing wrong with it, what is the probability that it lands on heads? And that probability is, of course, I think we know this, right? 1 out of 2. Okay, so the 1 represents the fact that we have one desired outcome, heads. But the 2 on the bottom comes from the fact that we have 2 total choices, right? Of course, it could have landed on heads like we want, or it could have also landed on tails. So there's some terms that I'm going to want you to know, and then you can structure kind of basic probability lessons and events for your students. So a sample space is just where you list all the possible outcomes. Anytime you have a list of items, you will usually use set notation for that. So all that means is curly braces. So for a coin flip, the sample space is simply heads or tails. I'm going to use H for heads and T for tails. So I just want to kind of introduce basic probability, and then I'm going to show you some classroom activities, and then we'll get a little more specific in the next lesson. Okay, so there is a difference. Again, some of these things that we're talking about today are things that you need to know, not necessarily things that you would ask your students, but you need to make sure and have a basic understanding so that you don't ask questions that are very difficult to answer. Okay, we want to keep them pretty simple, and you need to know the difference between, those easy probability questions versus the ones that actually require really a lot of thought. So experimental or empirical probability is the probability based on actual results. That's why it's called experimental. Okay, so an example of that is, we're going to practice this maybe in just a minute, but if you were to flip a coin 100 times, and let's just say in your version of that experiment you get 47 heads. Okay, that's completely possible, right? So we're going to come back to that in a minute, but this is often compared to theoretical probability, and theoretical probability is just what should happen in theory. In other words, it's not based off of an experiment, it's just what's supposed to happen. Okay, so what is supposed to happen when you do a coin flip? Okay, if it's a, quote, perfect coin flip, and you flipped a coin 100 times, you should get exactly 50 heads and exactly 50 tails, right? So I'm going to say you should, and I'm air quoting should because it's not always going to happen, right? But it's just in theory what is supposed to happen. So the key with experimental is we're often comparing what we actually get to what we expected to get. So instead of the expected 50, and then the last thing, and then we're going to look at some activities. The last thing is that you need to be aware of is for probability experiments to be valid, we really need to make sure that we do the experiment enough times. So the law of large numbers just says that if you perform any experiment, okay, and by experiment, that could just be you flipping a coin. It doesn't have to be, or you rolling a dice. It doesn't have to be something complicated. But if you perform any experiment a large number of times, then the experimental probability will get close to the theoretical probability. Okay? In other words, if I flip a coin 100 times, I'm much more likely to see some result close to 50-50 than if I just were to flip a coin twice. Okay? If I flipped a coin only 2 times, it would be highly possible that I could get a heads followed by heads. Okay? And then it would be a mistake for me to think to myself, oh, I got heads both times I flipped a coin, so it's 100% probability of getting heads, right? The problem with my experiment is I didn't do it enough times. I didn't flip that coin enough times. Okay, so hopefully you already printed this out, but if not, go ahead and pause the video. You need to print out the probability packet that I uploaded for this week. Okay, it's a little bit of a rough copy, but it looks like this. Okay, so if you haven't done that, I need you to go ahead and go print that, okay, because we're about to look at a few of the activities in here. We're going to do our best trying to do this, you know, via the internet, but I want you to look kind of at a few of these, and the focus needs to be that you can do some of these probability activities easily in your classroom with, you know, items that are readily available. All right, so let's look at this first page first, or page 181, rather. Okay, so we're just going to kind of go through some of this together, okay? So this involves tacks that look like this. I don't know if you can see from the video very well, but it's like the old school tacks, the one that don't have the plastic on them, okay? So this would probably not be an experiment I would want to do with younger kids just because I wouldn't want to give them access to sharp objects like tacks. But this is one that you could demonstrate for them, okay? And again, probability, you don't have to buy fancy manipulatives, okay? A lot of times you can do it with just the equipment that you have, okay? So hopefully you can see these are just those metal tacks. All right, so let's read this experiment. Out of 100 tacks you dropped, how many landed point up? Okay. Now it would be really challenging for me to try to do 100 tacks and count those. So one thing that you can do is we can just do them 10 at a time. So that's what we're going to do here. Okay, so we're going to kind of write these down and we're going to get like live results here. So we're trying to find out how many have the point up. So all of these that are like on their side, we're not counting those. So notice in this case there are 5 with the point up. So we're going to put a 5 here. Okay, and then we'll do it again. Notice if we do 10 trials of 10 each, then we'll have 100 tacks. Okay, notice I got different results this time. If you look, okay, I'm going to space these out a little bit. Only 8 of them are up. Almost dropped one. All right, so we'll kind of do these like a little faster. This one, it looks like there were 6 up. This one, it looks like there are 6 up again. This one, it looks like there are 5. Sure we get them all here, right? 7. So notice in our different trials, we're not always getting the same result, right? And frankly, if you did this experiment yourself, you wouldn't get the exact same results that I'm getting. 7, 3, we got 7 again. We're on a streak of 7 here. So let's see for the final 2. 7 again. And then lastly, it looks like that is 5 this time. Okay, so let's move those off to the side. So out of 100 tacks that we dropped, or that I dropped and you're observing me dropping, how many landed point up? So notice we can just add these up, right? So 13 plus 12 more would be 25, 30, that's 28, so that is 58, and then 63. So 63 landed face up. Okay, so what is the experimental probability? So remember, experimental means use the results we just got, okay, and try to determine what the probability is. So the number with the point up was 63, and then notice that's out of 100. Okay, so notice if we wanted to, it'd be really easy to talk about 63%, right? Because I actually made it per 100. 100 is a really nice number to use because you can change it to percentages really easily. So let's see if we can figure this out. If 63 is what we expect to get out of 100, okay, the question is how many do we expect to get out of 300? Okay, well, we practiced this already, right? So we can just call this our x and we can cross multiply. So this would be 100x equals whatever 63 times 300 is. So we probably want a calculator for that, right? 63 times 300 is 18,900. And then if we divide both sides by 100, when you divide by 100, remember you just kind of take off 2 zeros. So it looks like we would expect about 189 out of those 300 to be point up, okay? So what is the experimental probability that this type of tack will land point down? You don't have to redo the experiment, right? So let's think about that. If there were 63 where the point was up, that means there were 37, right? So I would do 100 minus 63, or 37 with the point down. And so notice 37 out of 100 would have had the point down, right? Or 37%. Notice I also could have just taken this 63% and, subtracted it from 100. Okay, so those kinds of experiments that you can do are really, really easy to do with your students. Okay, you could do coin flips. The only thing about coin flips, if you do pennies or something, is you'll have some students want to keep the money, okay, which may not be a problem, but you want to have enough so you can do a classroom set. But also just, frankly, money's kind of, unsanitary sometimes, so definitely want to keep those things in mind. But a coin flip would have been just as good. But notice I like this activity because it didn't come out to be 50-50, right? And it's just kind of a random object that we could use from the class. Okay, the next one I want to look at is called the penny grid. So your back 2 pages of the packet you printed out, there should be 2 grids that look like this. Okay, one with smaller squares called the 2 penny grid. Notice it's called that because it's literally the width of it would be about 2 pennies. And this is the 3 penny grid. Okay, so I want you to get this out. And so we're going to do this next activity, number 2 here. Okay, if you've ever went to like the state fair or something, or any even local carnival, they have those games where you have to like throw a coin and hit. Not just hit, but try to make it inside a bucket or inside a bottle usually, and that's really hard to do. So this activity, we're going to do a series of spins, okay, and we're going to try to see, does it land in the square? If it lands in the square, we quote win the game. Okay, notice that one didn't, right? And then if it, I'm a horrible spinner, if it lands on a line, then we don't win. Okay, so you could have your students do it. Notice I didn't win that time either. Okay, so I want you to take your penny grid. You can do this with somebody else if you want, okay, but I want you to look at page 182. I want you to actually spin the penny 24 times, okay? And then I want you to record how many times you won versus how many times you did not win, okay? So I want you to pause the video and try that, okay? Take your penny grid. I know you can find a penny around your house somewhere. Look under the couch cushions or something, okay? All right, so hopefully you did that experiment, you paused it, okay? So it says based on your experiment, which means everybody in this class shouldn't have the same results, okay? So notice we should put 24 on the bottom if we're trying to find the probability, right? And this is where your number goes, okay? And what number should go here? You only win, so it says when you land inside the square. So we're going to say the number of times inside square should go there. And then notice you could change that to a decimal. Okay, so I'd want you to change it to a decimal and eventually a percent. Okay, so now let's talk about kind of, I don't know what your percentage was, okay, but it probably, unless you're really a skilled spinner, I guess, it probably shouldn't have been as high as 50%, okay. All right, so let's talk about why. Okay, so this is a little more advanced activity. So I want us to look at this grid here, okay? And I want us to talk about, so if you read this, this says that A, B, and C would be points where it was the middle of the penny. And the question is, would you win the game if the middle of the penny was on A, for instance, okay? Notice A would be a winner, right? If the middle of the penny was on C, you would win, right? But what about B? If you put the middle of the penny on B, notice it doesn't win, okay? So let's do part C. It says which of those would have been winners if the letters represent the middle of the penny. Okay, A and C would have been winners. So what we can actually do is we can actually use concepts of area to discuss probability here. In other words, it does have something to do with the size of this square, right? So as long as the center of the penny lies in the shaded area that we're about to do, then we win. So it's a little challenging because, of course, we can't see through a penny. In other words, what I want you to do is go to the edges, right? This is the bottom value that I would, quote, win at, right? This is the top value that I would win at. So if you kind of picture it and kind of draw there, that's about as far as I can go for the center of the penny to be, quote, a winner at this game, right? That's about as far as I can go. So that's about as far as I can go. I'm just kind of guesstimating this, okay? You could, you know, make pennies out of paper where you could kind of see through them a little bit. So notice anything where the center of the penny is here, we would win. Okay? As long as the center of the penny is in that section, then we would win. The problem is, so you're only going to be a winner if you're in the shaded section, but compare that to the area of the whole thing, right? So I want you to estimate the shaded region percentage. Remember we did this with percentages before with the 100 square. Okay, so if you estimate this, it's not 50%. Okay, if you take this, these strips, the white strips are bigger together than the shaded area is. So I would estimate this to be about 30 to 40%. Okay, just an estimate. So the question is this a fair game? In other words, will you win half the time and lose half the time? And the answer is it's not a fair game if we want to win, right? It's not a fair game for the player. You will lose this game more than you'll win. And it's all because of area, right? By the way, how often will you lose this game? If we will win 30 to 40% of the time, remember that means we'll lose 60 to 70% of the time, right? So let's think about this logically. If we instead play the game on the 3-penny grid, shouldn't that increase our chances of winning? Okay, the answer is yes, right? It should increase our chances because notice all of this area that's a winner now, right? All of this mess, right? Like I can land my penny just about anywhere, okay? So you don't necessarily have to do this. Okay, we're just going to kind of skip to the part where we figure out what the or about what the percentage is. So let's skip down to here. Okay, if you have time, you could go ahead and flip it, but I think it's pretty obvious that we're going to win more often here. So we're going to do the same thing. We're going to try to figure out where we think the winners are, slash, you know, if we fall outside of this shaded area, we won't win this game. So I'm not looking for you to get out a ruler, not really looking for that, just looking for general. Notice how much bigger this area is, right? Which means, hey, we got a better chance of winning. Anything in this area is a winner. Okay, so I'm just going to say winner would be here. So if you wanted to estimate that area, I definitely think that it's over 50. So I would probably estimate that shaded area. I would estimate that there's probably 60%-ish shaded. Okay, so by the way, this still technically isn't a fair game. If a fair game by the definition of the page before this one was that it's 50%. But I like this game better, right? Because it's not a fair game, but this time it's in our favor. Okay, so notice just how easy that was to do something like that, right? So, so you could do an activity like that. Notice this brings in probability, but also things about area. Okay, so there's really kind of some different levels of challenges that you can have. Okay, let's look at number 4. So I'm going to modify this one because I don't have any note cards with me, so we're just going to use Post-it notes. So what it says is that we need to have 3 index cards. I just forgot to bring my index cards with me. Oh, actually I didn't. All right, so we're going to get out some index cards, and we're going to label them on both sides. Okay, so one card we're going to label with an A and a B on one side. Okay, so I'm going to move this out of the way. So A on one side, B on one side. And then this card we're going to label as B on one side and the other. Notice I put B1 and then B2 just because I would want to know, hey, which B was it? Okay, and then the same with the A's. I did a card with A on both sides. Okay, so the question is that we're going to ask ourselves, so let's flip the page. So we're going to be on page 184. So it tells you that you're going to cut out these cards, you're going to label them, and then you're going to kind of put them behind your back, mix them up, okay? And you're going to pick a card. So if I mixed my cards up and I just picked this card, the question is, what's the chances we're supposed to find, what is the probability, I'm trying to read, what is the probability that the letter facing down will be different than the one facing up, okay? So notice the other side could have a different letter, which notice it does in this case, but it also could have not had the different letter, right? Okay, so you would do this experiment. I think it tells you to do this one 24 times as well. So you're just going to mix up your cards without looking. If you can get somebody to help you, mix them up. Okay, close your eyes, randomly pick one, and then you're going to record, is it the same or is it different? Okay, so I want you to pause the video and try that 24 times. Mix the cards every time, see what you get. All right, so depending on your results, notice you should get something over 24. Number of times there was a different letter down would be whatever you put there, and then over 24. But let's see if this would be your experimental probability, right? But let's see if we can come up with a theoretical probability. Okay, so here are your options. We have a card with A1 and A2 on it, right? We could flip A2 and it could be another A under it. Okay, I'm listing all the possibilities, right? We could have the card, if it starts with B1, it could have B2 on the other side. This is where if you physically made the cards like I asked you to, this will be a lot easier. But that's our 6 options, right? In other words, I only have 3 cards with 2 sides, so I only have 6 opportunities for, possibilities, okay? So this is the top face, right? There's only 6 choices for the top face versus the 6 choices for the bottom face. I mean, 3, right? But I'm talking about the pair of top face versus bottom face. Okay, so the question is, in how many of these outcomes right here is the top face of the card different from the bottom faces? Okay, remember, we only said A1 and A2 because we wanted to differentiate between them. It's still A's, right? So notice there's only 2 times where we have a different card, right? Here and here. Here we have 2 A's, here we have 2 A's, here we have 2 B's, here we have 2 B's. Only twice did we get a different letter on both sides, okay? So in how many of these outcomes is the top face of the card different from the bottom face? So that would be 2. So what is the probability of selecting a card which the letter on top is different from the bottom face? Okay, it's going to be 2 out of 6, right? Or 1/3. That reduces to 1/3. All right, so we can answer the rest of these questions, but my point is, you can create for yourself all kinds of probability activities, okay? They don't have to be super challenging. Another one that I've seen people do is you could do the colors. You could make little cards like this, and you could put them in a bag and shake them up, right? You don't even have to have, a lot of the standardized testing for students of this age will say, like, there's a bag with 2 blue marbles and, 1 green marble and however many red marbles. What's the chances of you drawing a blue marble? But you don't even have to have that. You can just make your own, okay? So if I were to randomly pick one of these, what would be the chance that I would pick blue? Okay, notice there's 1, 2, 3 blues out of how many total? 6, right? So I'd have a 3 out of 6 or 1/2, okay? What would be the chances if I randomly picked that I would pick a green? There's only how many greens? 1, right? 1 out of 6, okay? So you don't have to spend a lot of money in your classroom to have things that are meaningful, okay? So I'm going to put some of these things up. There's more stuff in this packet that you can kind of practice with. I want to show you some different things that we're going to use in our lesson next time that I want you to kind of be familiar with. All right, so the first thing is there's some common probability tools we call them. Okay, so notice we can have a traditional die like this black one. Okay, notice instead of the dots, it has the numbers. Okay, this is just a different kind of dice, or it's a die technically if it's only one. But this, we have different options. Okay, this option has many, many different numbers on it. This one has a crazy number. Okay, so you don't have to always pick traditional dies. This one has 9 sides. Okay, so if I roll this, what should be the chances that I roll a 7? It should be 1 out of 9, right? Since there's one number that's a 7 and 9 total choices. Okay, there's also, I don't know if this is going to show well, but I really like to use these in my classrooms. You can do a double-sided, I don't know if you can see, but this is a bigger, let me see if I can get out of the glare. This is a bigger die with a smaller one inside. So if you look, they're actually both at a 4, but you can roll this die and notice I have a 2 on the outside if you look at the white dots, but it's a 6 on the inside. So it's like a double dice roll with just one object, okay? So that can be kind of helpful. We're going to talk about this next time. So I want you to be familiar with some common tools of probability, okay, like a coin flip, like a die roll. I also want you to get a deck of cards and play with them, okay? We're going to talk about this next time, but I want you to get a standard deck of cards if you don't already know kind of what the possibilities are, and I want you to think about kind of how many different options you have. By the way, take the jokers out, no jokers, okay? So I'm just talking about a standard deck. So we'll talk about that in a little bit. Okay, so there's some common probability exercises that you can either cheaply or sometimes even for free talk about with your students. Okay, dice rolls are dice are easy to find. Coins are easy to find. Deck of cards is not difficult either. Some common probability exercises that you can either cheaply or sometimes even for free talk about with your students. Okay, dice rolls are dice are easy to find. Coins are easy to find. Deck of cards is not difficult either. Some common probability exercises that you can either cheaply or sometimes even for free talk about with your students. Okay, most classrooms will probably have spinners like this, okay, where you can spin things, right? What should be the probability of any of those colors? Should be 1 out of 4, right? Notice this one, the probability of any of those numbers should be 1 out of 5, right? This one, the probability of 1 out of 6, any of them should be 1 out of 6, right? And so on and so forth. Okay, notice this is a whole kit. Okay, this one's interesting, right? The probability of green should be higher. How come? Because it's a bigger space, right? So it takes up half the circle. So the probability of green in this case is a half. These are each a fourth. Okay. So the last thing I want to do with this lesson is I want to show you how you can, so I just showed you some really cool spinners that I really like. I like to have a classroom set, but you know, you never really know what materials you're going to have in your classroom. So I want to show you how you can actually have your students make their own spinners for free. Well, for the cost of a safety pin, or not a safety pin, but a paper clip. So if you have a paper clip at home, I want you to get it and kind of bend out the side like this. Okay. Notice that this will make a spinner or a pointer kind of thing. So what you can have your students do is, now I'm not going to be very exact with this, but you could have them even trace a perfect circle. So we're just going to do kind of a rough estimate here. It's not really showing up, so let me do it in pen. Okay, it's better if you can have a perfect circle, which I don't really have here. But then what you can do is measure the center, and you could even set up the circle for them. And then you can put your pencil point at the center, and then it becomes a spinner. Okay, and notice we can make the makeup of the spinner anything that we want. So I could make this red. I know this is a little rough. Okay, and then I could make maybe this green. Okay, you can make a much prettier one at home. And then maybe this purple. Okay, and then you could have them practice spinning it, right? Now, which color should we land on in the one that I drew most often? We should land on red most often. So we have a purple there. Okay, I'm trying not to get in my own way here. That was a red, purple. So you could kind of record your results, right? So what's the experimental probability of getting red? It would be 1/2, since it takes up half the area. But in practice, you might find, you know, if you were to spin this 20 times, you might not get 10 times in the red. Okay. So the point is, you really don't have to spend a whole lot of money to have some meaningful activities in probability. Okay, and I hope this lesson kind of showed you that. Okay, so for next time, like before you watch the next video, I want you to write these things down. So for next time, I want you to list the sample space for a coin toss. Kind of already did that one if you look back in the notes. But also a die roll. And we're just going to assume it's a 6-sided die. I mean, I know I just showed you some dies that were different, but we're going to assume it's a normal, regular die. Okay. And then I also want you to look at your deck of cards. Remember how I told you to get out a deck of cards? And I want you to answer some of these questions if you don't already know them. Some of you who've played cards a lot with your family or something, you probably already know this. But some of us don't have as much experience with cards. That's why I'm trying to talk about it. So I want you to tell me how many cards there are, which I just kind of told you that. I want you to tell me how many suits. Suits represent like the shapes that are on them, okay? And I want you to list them. I want you to tell me how many types, okay, and by that I mean A through K, right? Ace through King. I want you to tell me how many of each type. And also the colors. That's probably an easy one, right? And list those. Okay, so I want you to have a pretty firm understanding of that, like before you start watching lecture video 2 for the week.